We just talked about compound inequalities and or the typical ones and went towards each other or went away from each other. These ones are not typical, they are atypical. So we are going to go ahead and show you what a different type of solution would look like. We're really more concerned with overlapping for and whether it is on either arrow for or. So for number 29, we will add 5 to both sides to get n is less than or equal to 8. We'd also have another solution, or when we subtract 10 from both sides, we'd get n is greater than a negative 8. And these are my two solutions. Now, right off the bat, you can see that the number line isn't really big enough for this, but we're going to sort of fudge it in there a little bit. N is less than or equal to a positive 8 gets a closed circle on about where positive 8 would be. And less than is talking about to the left. So that is all the points this direction that are on the left side of it. Now, n is greater than a negative 8, here's negative 7, negative 8, gets an open circle, and that's going to talk about all the numbers that are to the right. Now, this looks more like a typical AND graph, and a common mistake for students to make is that they shade in the overlapping area regardless of whether it says AND or. Remember, this one says OR. And since this one says OR, we are concerned with whether or not it is on either of the two lines, the red one or the green one. Now, if we look at the red one goes back forever. It keeps going towards negative infinity forever and ever and ever. But it only gets up as high as positive 8 right here. But the green line goes to positive infinity forever. But it only gets as low as negative 8 down here. Now the thing is that any point on this number line exists on one of the two arrows, the green or the red. So it is not a situation where we're eliminating any points. This will work for all real numbers. So that is our response in this case. If we have an OR graph that goes towards each other and overlaps like this one does, then all real numbers would work with the situation. It works n is less than or equal to 8 or n is greater than negative 8. Of course, any number would meet those two conditions. Number 30 is slightly different. It is, again, an OR graph. So we've talked about the two types of OR graphs so far. They go away or they go towards each other. Let's just go ahead and do this and see what it looks like. To get rid of the 10, we'd multiply both sides by 10, and we'd have p is less than 10. All right, simple enough. Then we'd do the other one, or we'd divide both sides by negative 2. And when I divide both sides by a negative 2, don't forget that we have to flip the inequality sign around because we're dividing by a negative. And this will get me p is less than or equal to a negative 1. Now, if I'm going to go ahead and graph these, you'll notice, again, my number line is not quite right, and there's a good reason for that for this one. The reason why it's not quite right is because if I go ahead and graph the p is less than 10, that is everything from 10 going that direction, right? Not including 10 because it is a simply less than sign. Now, negative 1 is way back here already. Here is negative 1. If we sort of, do a little ellipsis and dot, 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 here's negative 1. Less than or equal to that is still going that direction. Now, since we're talking about an OR graph refers to either of the two situations. Any point that is smaller than a 10 is also going to be smaller than negative 1. So it would be sufficient to say simply p is less than 10 as my answer to this, because both conditions would be met if p is less than 10. Even one of the two conditions would be met if, say, your number was 9. 9 is in the solution because 9 is in this part of the solution.